Awesome! Fantastic. Hello. Welcome. So good to see so many people still awake after lunch. This is fantastic. We are going to talk Git here today, which is probably the least PowerShell heavy session in this entire conference. I think I have like one or two, lines, but split up in more lines of PowerShell. The rest is more or less just Git commands. Before we get going, huge thanks to our sponsors, Chocolatey, Jane Street, Iron Man Software, Knowledge Factory, and Synergy. Without them, this conference wouldn't happen. We wouldn't be here doing some awesome stuff. Go buy their things, look at their stuff, and play their ping pong tables. I may be partial. My name is Björn Sundling. I am an MVP and MCT, and I have lots of other really, really cool titles that I'm super proud of. In my day-to-day life, I do consultancy work for Knowledge Factory, which is part of Advania, where I do DevOpsy stuff, Azure stuff, all kinds of cool things. Outside of that, I have a dog. I walk a lot with my dog. I play metal music because, of course, I do. I live in Sweden, like everyone does. It's what we do. And, some other stuff. But most importantly for this session, I am absolutely not a Git black belt. In fact, compared to the people who are good at Git, I'm probably a Git barely a white belt. But I hope you can sort of oversee with this and don't give me too hard questions afterwards. Because Git is really damn hard to understand. It contains approximately 150 different commands. That's a lot to remember by heart. They are separated into two categories. We have what's called the plumbing commands. They are basically the commands you very rarely see or use. We will see some of them in my demos, but plumbing is mainly what we would refer to as internal functions. But because Git is not PowerShell, they are very much publicly available and you can run them whichever way you want. This means, of course, that the other half of them, the rest of the 80, are porcelain, because on the other hand of the plumbing, you have the porcelain throne, right? I don't know if that's the point, but it's really hilarious to me that they named it after my porcelain throne. And these are the commands we usually run. These are the pulls and the pushes and so on. These commands contains about many parameters. And because of this structure, the fact that you have internal or plumbing and you have the porcelain commands, this means that there's about 1 million different ways to do the same thing in Git. There are so many different ways to reach the same plumbing commands. So what I'm about to demo is probably not the only way, or it is not the only way to solve these issues. It's one way to solve the issues. And if you have other options or other ways, feel free to tell us, because I'm always curious and want to learn more. The agenda for today looks a bit like this. We will look at some setup. Get Git to working for you, not setup.exe or your setup shell script or whatever you use, because I'm going to assume that you already have Git installed. We will look at adding and restoring code. And yes, I know that in the session abstract, it said like, what happens when I already know how to add and remove code. So we will not look at the, git add dot or git add a file. We'll look at some more detail what you actually can do outside of this. Maintenance, random stuff that's not just for versioning. We can do all kinds of cool shit in Git, really. And depending on the time and how fast I speak, please scream at me if I speak too fast, Rob. We will look at some other sort of cool stuff that I discovered through the process of understanding Git and the process of writing this session. But we can look at this session sort of as a way of, how every developer, when we start learning something, we just throw commands in a file. This file grows and we sort of discover, and every now and then we have like some comment. This command does this command does this. This session is basically me cleaning up my Git file and making it understandable and sort of getting the grasp of what this file does in the back end. But before we get going into demos, I'm having a pre-session Q&A from a totally anonymous person who asked me a really, really strange question. Why are you doing this using command line? Why don't you use VS Code? Hey, I can do all of this with just a couple of mouse clicks. That would be a cool controller. A couple of mouse clicks in whatever GUI I prefer. And yes, you can, but that doesn't help you understand what happens in the back end. If I just click the small circle that says synchronize, I have no idea what's actually going on. And I want to know what's going on. So that's why we will simply be looking at Git CLI today, the command line interface. And so with that, I think that's enough speaking for one session. Let's go look at some code. Like I said, I'm going to assume you all have installed Git, because if you haven't by now, it's time to start doing so. Git is default for every developer to save stuff. One of the issues that I always encounter with Git is that I am a lazy installer. Either I use wingit and say wingit install quiet, or I download the setup.exe and say next, finish, zoom in, thank you. And that has one sort of downside. If you run a Git command that requires some kind of input, that could be a commit message, a merge message, whatever it is, it will open VI. And as every developer knows, VI is impossible, and if you ever end up in it, you will have to throw your computer away because it's useless by now. So the first thing we're going to look at is how we can fix this. And we're doing this by simply saying git config global. That means this configuration is for everyone, and say that the core editor for Git commands, if it needs input, should of course be Visual Studio Code. So we run this, and the output is absolutely nothing. But this is kind of interesting. So why do we have to have the wait flag? Well, because code actually accepts lots of weird parameters. It's a full-on CLI in itself. We can see this by just running something like this, and of course we have no console, so yeah. You have to accept the fact that we can do this, of course. There. Code has a lot of parameters, and you may actually want to add your own if you want to do it, but just using git config global, we can set VS Code as our default editor. But this isn't really enough. We also need to define the merge tool, which is if we get a merge conflict, and the diff tool. So we can just run this, and we add the same command, wait. Wait simply means do not continue my command until code is done, which means pause, break, do not perform the rest of the Git process. If we forget the wait part, you will end up in a weird situation where Git tries to do stuff with an open file. And so we run this, and we set up VS Code as our default editor, and we will no longer end up in VI. If you're using lazy installations as I do, this is sort of the first thing you should always do to be able to keep your computer. Now this also, of course, carries on to a next question. Git config. We can do git config -- list, and we can say, how does my configuration actually look, and look at it. And Git contains a lot of configuration stuff. It also contains paging, like this. There's a lot of configuration stuff going on in Git. We could, of course, improve the layout because we are PowerShell nerds. Let's just skip the first one and do this one instead. Did I say we were not doing regex today? There we go. Now we have some coloring and some separation and some more stuff. So there's a lot of more configurations you can do in Git. You should look into this. In fact, there's endless amount of configurations you could set up to get Git to behave the way you want. But what's most important to sort of keep track of is the scope. Because Git works in 3 scopes. We have the system configuration. That is something that Git has for every user on this computer. These ones you barely ever touch. It's like how we use large file system objects and so on. But we have the global configuration. This is the one that configurations in global scope is valid for every single repo that you're using. Which means, well, most of you, as you start using Git, will probably get the error message say, hey, you need to configure your email and your name. Use these commands, git config -- whatever. And they will end up in the global scope. Now, this is also interesting because I didn't really realize it, but Git doesn't really support the same character encoding. So yes, my name is Björn Sundling. Apparently according to Git. So we have the global scope. That's valid for everything. And we have the local scope. The local scope is for this current Git repo that we are working in. And we can overwrite these sessions, so we can actually say that, you know, in this repo, my email address should be something different. Or in this repo, I should work as my work account or whatever. Really, really useful stuff in there. So, we have our configuration, and we have some tracking of the scope that we are working on. How many of you are using multiple Git host servers, as in, I work a lot with my company, and I work a lot with my own stuff, and I am not one of those good people who keeps track of which one goes where. So this is actually where we're sort of heading with this. One of these settings that you can use in your global config is called include if. And this is one of those overlooked and really, really useful settings. We can, let's open code and open our file. We can have our default git config. This is basically saying everything I have global configured for my own Git sessions. And in the very bottom, I have a couple of lines saying that if you are in this folder, yes, Advania SE is where I store my company stuff, then you should also include this configuration file. And what's in this configuration file? This is my corporate email address. I'm still named Björn. But now, because I have said that if we are in this root folder over here, that I showed you in this one, if the path contains this root folder, overwrite my name and email address with the settings for work. How does this look? Well, we're going to do some clear screen because, of course, I forget to do this all the time. So let's go into a repo for my workplace, and we do git config and say, which email am I working with? Well, currently it's bjorn.sundling@advania.com. Now let's go to my own repo, if I can find the button. And it says bjorn.sundling@gmail.com. I'm talking Swedish here. So, why should I do this? What's the reason for it? Well, have you ever encountered the scenario when you go to GitHub and it says, this commit was done by Björn Sundling and Björn Sundling, or this commit was, and it's just my name twice? The reason is you have committed twice or committed more than once to this branch or this pathway using different email addresses. But you have the same name, so if I work on my work computer and then I do the same on my home computer, then it will end up with 2 different accounts according to Git history. So in this way, we can actually separate them and make sure that the correct email is set everywhere. Now, this is really good, but it also highlights one of Git's, according to me, major issues. Because this is just a configuration setting. I can set my email and my name to anything. So if I want to be Jeffrey Snover, I could just say git set my name as Jeffrey Snover and my email to the best inventor in the world at Microsoft.com. And that would show up on GitHub as, hey, Jeffrey Snover is trying to do a pull request to you. Fantastic. Yay! So, where does all this lead us? To a fantastic feature that's highly overlooked, supported in at least GitHub so far, and in Git natively, and that is code signing. Not code signing as in, I want to sign my PowerShell code, but we can use SSH to generate a key, or if we have SSH installed, which all of you probably should have, we can just take our normal public SSH key, and we can do some regex magic. I'm going to create a new key here. And now I have a key. If my F8 button... Oh, wait. I need to give it a passphrase. True, yeah. Passphrase, the password for this one, I'm just going to be lazy and say I don't need one. And now... Well, that's my key, my public key that I created. We can do some regex to actually capture the content of this key, because we need to have a specific part of it, which is the fingerprint. And yes, that's my computer name. Now you have everything secret that I hold dear. Don't steal my identity, please. And so now we are going to create a couple of files and make sure it's a signing key. And if we log into GitHub, this is my public key, so it's nothing secret. But we can create signing keys. And sorry that I forgot to change this one to light mode. Let me know if you can't see it. But we can add new SSH key here. We have to make sure that it's a signing key. Fill in our SSH ID like this. Give it a type. Whoop. Sorry. Thank you. Okay, there used to be a button up there that says new key, and then you say signing key, fill in your key value, which is what I just created, the SSH key. Fill it in there, so it looks a bit like this. I have added 2 computers because these are my 2 main working computers. Now, we need to tell Git to actually use this. So we say, configure this with a default format of SSH. Git has had signing for a long time, but we normally use RSA keys. And RSA keys are quirky for a Windows user. It requires a bit more. But SSH is built in. So we can just add this command and say that, hey, this is the path to my public key. And yeah, all of this code will be available on GitHub, so you can download it and look at it and apply it to yourself. So yeah, but we can configure Git to use my key and say that if I sign something, this is the public key. Now, when we do this, we need to add the -s for -sign to our commit. So when we do git add and when we do git commit, and it will add this key. We can also say, hey, set a global setting to automatically add the -s. This git config -- global commit gpg sign true. This will mean that every single commit I have will be signed by the key that I'm pointing at using my key file that I can configure in my include if file. And so I can use different files for different things, different projects. We can, of course, add this now. If I say commit, it will sign my commits. We can, of course, add this for stuff like tags or whatever. So everything in Git can be signed. And yeah, okay, this one we can skip. In order to verify it locally, you need to set up some more stuff and say that this is my file, this is where the allowed signers are, and then I can verify it locally. But the important thing to know is that if we do this, and sorry, I'm going to zoom out a bit, and we're going to go to there we go. Nope, there we don't go. There we go. Now, since I have added this to my commit keys in GitHub, if I go to my commits here, see this little green verified flag? Sorry. Okay, here's my commit history. It has fantastic messages. Don't look at them. And on the end of the line, we have a verified flag. This means that my key that I have signed this commit with is connected to my GitHub account, which means if I now say Jeffrey Snover, it will say, nope, you are not Jeffrey Snover, because you can't sign your key and it can be verified with this. You can even in GitHub set up so that we require commits to be signed. And if you don't sign them, we can't trust that you are you, and therefore we cannot accept your commits. So commit signing is one of those really good tools that you should set up, especially if you're using corporate accounts or if you're using a corporate GitHub enterprise or something like that, mainly because it prevents random people from showing up in your history, and you can have a way cleaner Git history looking at what goes on there. So, do use signed commits. Now, we have already looked at some of the commands, like you need to remember -s if you want to sign it and so on. Git actually supports some effectivization of this. We will look at some of these commands later, but we can use aliases in Git. So instead of having to remember git commit -s-m and then give it a message, we can actually say, hey, git make a global alias and say, for example, sc, make it a signed commit. This will simply say that if I do git space sc, replace sc with whatever is in this line. So I just do git sc and give it my message, and it will work just as if I signed it manually. Git aliases is actually quite cool. Of course, just like with PowerShell aliases, do not use them publicly as in somewhere else. Do not expect others to have them because they are very much not global. But we can help ourselves by sort of not having to remember stuff. So we can do this, or we can say something like this, because this command doesn't really do anything. I just added a cln, and I can now do git cln. And it will say these are the things that you have added. We will look at this specific command soon, but yeah. Now I don't have to remember the entire command. I can use an alias instead. What's really cool about this one, let's just say, I'm going to remove this before I mess something up. What's really cool about this is that you can add an exclamation mark before your command, and then you can run whatever you want in a Git alias. So we can say, hey, Git, create an alias for PowerShell and run this command. And now I can do with the git svc. And it will start PowerShell, and it will run get service Xbox. So you can build some really cool aliases by injecting some PowerShell code and PowerShell scripts and your functions, and like, hey, make a git command or a git alias for cleaning up my git history before I actually push it, or make a git alias for, I don't know, deleting my root before I do stuff. You can do some really cool stuff with this. I'm gonna remove it, because otherwise I will do some really weird stuff with it. And just as we can configure, every single configuration has a -- unset that simply says remove this line from my configuration file in the scope I defined right now. So setting up Git, yes? There is, okay, the question was, is there a way to list those aliases? Yes, there is. You do git config -- something that I can't remember right now, and then you say -service, like filter out. The git config list basically lists all your settings, and you add just one parameter and say filter on this value. Like I said, I'm not that good at Git. This is the reason I have a configuration file to help me remember all of these commands. Yes, from the back. That's an interesting question. The question was, I have a bunch of verified commits in my commit history, but I've never set it up using SSH. So in one way or... Rob, thank you. Wait.
It's because in the browser you set it up to enable signed commits when you come through.
Thank you, Rob. That's how we do it. Do not stumble. Thank you, thank you. Thank you very much. So yeah, great questions, great questions. We are actually running way over time, so I include this. Again, you can find it in the repo later, because git ignores should be done. I found a really nifty alias you can use to do some really cool git ignores. We're just going to run it quick and say that, hey, we're going to keep deep breaths. Okay, lesson learned. Do not run during presentation time. Okay. Git ignores is one of those things we should set up. There's a nifty little alias that can list all of these and create git ignores for us, so we can say something like C#. Nope. Okay. There we go. Let's create an action script. And some cake. And then we go enter. And we create git ignore files. So let's look into our repo. This is the repo we are looking at. I just created a git ignore file containing a lot of stuff because I never remember what to include in my git ignore file. What is cool about this is that we can also run this command afterwards. So how many of you have ended up in a situation where you're like given a repo from an old customer, like, oh, here's a lot of code, fix this? I'm gonna guess a lot. The first thing I do when I do this is always create a good git ignore, and then we've done git rmr -- cached, which simply means all of the files that are actually dirt files. So for example, temporary files or binary builds and stuff like that that is supposed to be excluded, it will remove those. And we can take our blob of code, check it in as a first commit, run these commands, and it will clean up our repo to a good starting point. Very short demo of that one, because again, we are running very short of time. So we're gonna have to look at some more slides. Before we jump on into actually push and pulls, there's some good information to know to realize sort of where we're working when we are working in Git. Git contains a lot of levels and a lot of buzzy buzzwords. First of all, one of those we often stumble upon is the ref. A ref in Git is simply a reference to anything. Whatever it is, it's a reference. And paths, when we talk about this, when you read the Git documentation, you often stumble upon like paths like this. And if they start with a ref, it's just a reference to a point in time. We have my favorite. Git is created by Linux people. So you have heads, which is the tip of a branch, the latest commit in your branch. And then you have head, which is the current branch tip, which makes absolute perfect sense because head and head is totally different words, apparently. So these three sort of keywords we often stumble to when we reference our code. Where are we at in our code? How we jump to and from history in our code. But apart from that, we also have like the local instance of our Git repo, where we have our working directory. A working directory is basically where we are right now. Every file that is changed but not added is considered being in the working directory. As soon as we add it, it ends up in the staging era or staging part of it. And then we commit, which makes it our head. Because if we do a commit, it is now the tip of the branch we're working with. Apart from this, you have the other parts, like outside of my computer, because we still haven't left me. Local is everything I know, everything my computer knows. Every branch, every tag, everything. Remote, well, if I do a git push, it will end up on GitHub. That's my remote. And we also stumble every now and then upon the concept of upstreams. Now, I think this is a GitHub invention. I'm not sure. But upstream is basically where your remote points to in the next level. Now, why I felt like, yes, Justin. Well, actually, Yeah, it is technically just a remote. But why this is good to keep track of is because when we start working with Git stuff, well, we need to know where our stuff is and why it got there. So now we are not going to look at the back end of my slides. Let's go and look at some actual Git stuff. We're going to start by checking out some code. There we go. So I often do this. I open my file and let's see if I can add. And I have my function. Yes. I have my function. I'm going to fix the bug. I'm going to do something. So let's remove this line. There we go. That was the actual fix I was going to do. But hey, look. I have some spelling errors. You know, it's quite quick and easy to just go like this. And let's fix our spelling errors at the same time. Okay, awesome. You know what the issue is with this? Well, I just fixed 2 issues in one commit. This works. It's absolutely perfectly fine, but it's against all Git rules. So, git add, most of us, or most of me, use git add a dot or git add one file. But we can do a patch. Git has a nifty little feature called git patch. Now, if you see the bottom here, what git add patch does is that it keeps track of every single line that I changed and say, should I include this in my git add? So we can say, I removed this one. That was what I was supposed to do. So we're going to answer, yes, this one should be included. I also did a spell check. Well, this one is not going to go in my pull request right now. And if you see there, that's the sort of status of it right now. And I only included one of the lines in my commit. We can, of course, see this by using git state, git diff, and say, hey, this one, oh, wait. We have one red line. No, we actually need to do git diff stage and see what is committed. If we're on the right line the first time, then we can see somewhere, there we go. I removed this line in my commit. We can even go into more detail and say, hey, you know what? Highlight only, oh, come on, there we go. Highlight only the actual lines we changed, the actual words we changed in this one. We can combine this in whatever way we want to see whatever it is. But the good reason that we need to do this, that we should do this, is because we can then do something like stash what we have fixed but not committed, like this. Okay, I still remember to click Q. Let's do it like this. There we go. Now, stashing means take everything that I've changed, remove it from the file I change it, put it in a storage somewhere else, and keep it there until I say reapply it. So I stashed the changes, which is a spell check, and now I can run my pester tests and see that I only fixed the ones I wanted to fix. I only fixed the error I want to fix. I can do a git add and say that, oh, this commit fixes bug number what? And then I do git stash apply. We can open the file again if we want to, just so we see it. F8. No, wait. Maybe if we're on the right line. There we go. Zoom in. So we can see that the spelling errors are back because I tossed them away for now. And now I can do my tests, I can do my commits, and I can add this chunk of code, only this chunk that I was supposed to fix, commit it to my history, and then when I'm done, I run git stash apply, take the stash, reapply it to my code, and hopefully, I misspelled the first word still, but it will reapply this. So now I can keep a clean history and actually make sure that every commit commits one error, one issue, one task. Even though I fixed them all in one line, I can use that -- patch to fix them one and commit them in a good, clean history way. And once we're done, of course, well, we commit all the files like this, and we push it to our main. And hopefully it will not mess up my branches too much. There we go. Okay, this is all good. But if I'm on a branch and I do this, I will end up with yay many commits. And in GitHub or Azure DevOps or whatnot, we often do squashing and say that when we merge this is the main, I just want one commit. We can do this locally as well. So I'm going to check out another branch. And we can do something like this. Go! Wait, I can't type. Git. No, wait. I lost it. We're going to edit a file as well. There we go. Demo221 work file. Come on. Thank you. There we go. I edited the file in this, and I lost where I am. There we go. Thank you very much. Open the wrong file. There we go. I do an add and a commit, and if I do git log now, we can do it simpler. Log dash one line. We can see now that I have a couple of commits in my history, and if I do a push on this, then I will end up with yay many commits in my history up on GitHub and so on. On the standard way of doing this would be to say git rebase. Git rebase mainly takes your Git history and replays it on a previous commit or on a later commit and says, move my commits to another starting point. We will still have the same amount of commits, but this is the way we sort of do this normally. I discovered this one instead. If I can get... There we go. Okay. So if we look at my graph here, I have a lot of commits in... Oh, if I push this one, there. I have a lot of commits in this history, and a lot of branches, and a lot of other stuff. Let's say I want to sort of stash this in together into one nice commit, because I like to do commits, and I push them a lot, because I like to know where I am. We can do... Let's just pick one. A soft reset. Git reset simply means reset me to this part, this place in history. We use the ID, commit ID, or commit hash, to say this is the place in history we want to do, but -- soft lets us do this without removing any differences. So if I do this, if we look to the history now, let's just say, there we go. If we look to the history, it's quite long. Let's just say so I didn't. Yeah, that's good. If I do a git -- reset soft, it will keep all my changes from this history. And now I can just add one commit instead, like this. And suddenly, my whole history has one commit. I've squashed everything in my history together. If I do the same thing again, git log, well, suddenly we are quite a few commits less. Now, why would I do this locally? Like, oh, damn it, Git console. Why would I do this locally? Because like I said, I do like to commit often, but I don't like to push a million commits to my history. So before you do a pull request or before you merge it, do a git reset soft and create one pull request saying, these are the fixes I did. The problem with this is that we are rewriting history. And rewriting history in Git requires us to do a force push, because if I would just do this, I keep forgetting to this. It says, hey, you are behind me. You can't push this because you are behind me. GitHub says you are behind me. I have more history than you have, and therefore I will not allow you to push your changes. So I will need to say -force instead. And so we can rewrite history without having to remove history, and we can have a cleaner Git history doing whatever it is we want to do. So we can keep committing stuff all the time. Damn it, I'm really, really going out of time. Let's skip this one. We can restore files. This is quite a good demo. Okay. Restoring files. One of the things we often talk about when we say you should use Git, because Git is so cool, you can jump ahead and backwards in time. And if you lose something, you can restore it. And then I never do it because I keep forgetting how to do Git restore. So we're going to look at this. Git log --1 line makes a simpler Git log. And we're going to say follow this code around. And hopefully, well, we're not going to work. Okay. Well, yes, Git is a Linux program, which means paths does not look the way we expect them to. Easier way to do this, it's git reflog. This is one of the really cool stuff. This is local. We can just list the history. This is everything our local history knows. It's not remote, it's just local. We can just, as soon as we move computers, it's gone. We can use git show to show the contents of a history file. I need this one to work, actually. Apparently I messed this demo up. Okay, ignore it. We'll move on because I don't have the time. I'm really short on time. Git Bisect. Let's use that one instead. Git Bisect is a really cool command that lets us do a... it's called something based search. It basically says we started a Git Bisect and we have a different prompt. It says that we are in the bisect mode. So Git Bisect lets us say that this is a bad commit. And we can say that head, which is where I'm at right now, is bad. And we need to define the last known good commit. So in our history, I'm just going to go back and steal this one because I think I had it up there. There we go. There we go. So in our history, we say that, okay, the latest commit head is bad. This commit is good. And what Git will do now is it will check out the file splash in the middle of these commits, and we can open our file, the demo23 work file. If we had checked out the right branch, that's why nothing works. We can open our file and say, okay, this file is bad. So we go back and we say, this file is bad. And now it will check out the next one in the middle. And we can say, hey, this one is good. And eventually, we will end up splash where we messed up our commit. And we always get the commit ID back. So now we have the commit hash where our file went bad. In this case, again, I messed up my demo a bit, so this one is both good and bad. But we can use this and sort of query through history and say, where did this file mess up? And once we have this, we can check the commit ID. And now we can say, well, let's just chase this one. There we go. And now we can say, you know what? Restore the file from this point in history. We just need to figure out when it was good. And now we have read back our file. Git Bisect also needs us to do this before we continue. Git Bisect reset, because as long as we are in bisect mode, Git will not keep track of the history. So, okay, we need to Git Bisect reset, and then we can reset our file. Thank you. Yay! Now we have restored our file to this point in history. We can even do this using patch, and it does the exact same thing as in git add patch. So we can restore simple line by line or just restore this part. But we don't have the time because we are literally on 41 seconds and I have about half my demos left. Sorry, I'm big time. Is there anything you want to see specifically? Jay. Okay. Fact of the matter is, I ran out of time and I messed up because I have way more demos. But we have an open stage downstairs. Please join me for the open stage for more Git nerdery in about a couple of minutes. And if you have any questions, Well, ask them now or forever hold your peace, and let's just do the really, really quick slide through. There we go. Okay, any questions? Everyone is like, what the f*** are you talking about? Okay, do join me downstairs. I will continue to do more demo stuff downstairs with Git Nerdery because I have so many demos that I want to show people. But I am out of time. Literally soon. No. Thank you very much. Yeah, you're too late. We already did the applause. What's the question, Justin? What's my favorite Git command? Git add dot. No, wait. This is my favorite Git command. When all else fails... What? Okay. This is my favorite Git command because I mess up Git all the fucking time. Git is really, really hard. And believe me when I say I'm not lying, while creating this demo, I have had so many merge conflicts that my Git history for this one looks like a bloody mess. So when all else fails, cd ... rmd recurse force git clone. That's how you refresh everything. Throw your shit away and redo it. What?